So in our previous session, we have seen how to develop a APB code, like what are we going to develop. We have just set an expectation. We have seen what are we going to develop. Now in this particular session, let us see how actually we are going to write down the code for our APB master. Okay. So let me share my screen. The tool which we are going to use is Vivado. So in this, what I'm going to do is first click on create project and press next. And here I'm going to write down APB project is my project name. I'm going to press next RTL project. And here I'm going to create the file which is known as APB master. Okay. And press OK and press next and click on next and finish. So I've created a simple APB master. So let us wait for the file to be created and press OK and yes. So the file has been created. Now what I'm going to do is I'm going to write down the code for my APB master. So for my APB master, these are the signals which I'm going to have. Let's say this is my APB master. 1 minute. So this is nothing but my APB master. For this APB master, I am going to have input as clock, reset, and transfer. So if this is an input to our APB master, if this signal is equal to 1, then that means the master will enter into data phase, enable phase, or else it will be in setup phase itself. Okay. And input is address. So this address is given by our test bench. Okay. And W data is one of the input, like whatever the data the master should write, right? Okay, so that particular data is given by our test bench. Okay, and output is p select for selecting our slave, and another output as p enable, and to indicate whether we are in setup phase or access phase, and output is p address, and pw data, and p write signal, and p ready signal. So these are the inputs and outputs of my master, APB master. Okay, so that is what we are going to develop in this particular session. Okay, so let us see how to develop that particular thing. So let me zoom in. Let me write down my inputs and outputs of my master. Input, clock, input. It's an active low reset signal, and transfer signal, and 31 down to 0 address, 31 down to 0 W data, and input write signal for enabling write operation or read operation. So from the test bench, we are going to tell whether the master should perform a write operation or whether the master should perform a read operation. And output reg p select signal, it is an output, and output reg p enable signal, and output reg 31 down to 0 p address signal, and we are also going to have 31 down to 0 PW data signal, and output rich P write signal, so indicating whether it is a write operation or read operation, and input P ready signal. So these are my inputs and outputs of my master. Now next what I'm going to do is I'm going to declare the parameters for my state machine. Idle is equal to 2 tick binary 00, and parameter setup phase setup is equal to 2 tick binary 01, and axis is equal to 2 tick binary 10. So these are the parameters which I have declared, right? Next, I'm going to declare a few internal variables for my state machine. One is current underscore state, and another is next underscore state. Okay. So these are the parameters which I have declared. Now within an always passage of clock or neg edge of active low reset, what I'm going to do is If I apply my reset signal, if it is equal to 0, then my current state will be equal to idle. Else, my current state will be equal to next state. So this is my present state logic which I have written. Okay. And followed by next, which I'm going to do is next state logic. So that was my present state logic. Next I'm going to write down my next state logic. So this is reset underscore n, reset underscore n. Yeah. Now let us write down my next state logic. Next state logic is a combinational logic, so which I'm going to write down always with rate star begin. So here I'm going to take my case of current underscore state. Okay. So what I'm going to do is, if I'm in my ideal state, then if transfer is equal to 1, if the signal which is given by our test bench, if it is equal to 1, then I'm going to next state which is known as setup state. Setup. Okay. Else I'm going to stay in my idle state itself and followed by end. Now, if I am in my setup phase, then I'm going to begin this. I'm going to simply the phase which is known as access phase. End this. Now, if I am in my access phase, then begin. I'm basically waiting for my P ready signal. If my P ready is equal to 1, then I'm going to check for my transfer signal. So this transfer signal is basically used to tell whether to start the transfer or not. Okay, continue the transfer or not. If it is equal to 1, then I am going to set up phase again. That means I have one more transfer left out. Okay, or else I am going to simply next state is equal to idle. Okay, so this is my P ready. If my P ready is equal to 1, then this is going to happen. Else, if my period is not equal to 1, then I'm going to stay in the access phase itself. So this is what I have done and followed by end. Okay. And by default, I'm going to stay in the idle state itself and followed by end case and end. So this is nothing but my next state logic. Now let us write down the output logic. So when our output should become 1, so that is a synchronous logic. We are going to write down posage of clock or neg edge of reset underscore n. What are we going to do over here is, so we are going to first of all check for our reset signal, reset underscore n. Okay. So what are we going to do over here is, we are going to first of all make our p select to 0. This is an output, and p enable also equal to 0. This is also our output, and p address I am initializing to 32 tick h 0. This is also our output, and pw data will also be equal to 0, and p write will also be equal to 0. Okay, so this is what I have done and followed by end. Okay, now else I'm going to begin. I'm going to take my case of next state. So here what I'm going to do is, if I'm in idle state, then begin, my p select will be equal to 0. Okay, and my p enable will be equal to 0. So in my ideal state, these two signals will be equal to 0. And if I am in my setup phase, then my p select, I'm going to begin this, then my p select will be equal to 0. Sorry, I'm going to make it as 1 in the setup phase. P select will be equal to 1, but p enable will be equal to 0 because it is a setup phase. Okay. Next, my PW data will be having the data whichever the slave has given, and p write will be equal to write. Whatever the value the slave has given, that will be assigned to my p write. Next, if I am in my access phase, then I'm going to begin. P select will be equal to 1 and my P enable will also be equal to 1. Okay, this is what I've done, and followed by end. Okay, and end case, ending this, and end the module. So let me check whether I have declared my P select signal or not. So I have declared my P select signal as this. So this is a notation which I've used for this. Let me change it over here. Yeah. So master development is very simple. You just have three states. One is idle phase, and another is setup phase, and another is access phase. So basically, in your idle state, you are waiting for this transfer signal to be 1. If it is equal to 1, you are going to setup phase. Now, if you are in setup phase, you are not going to check for any other things. You are going to simply to access phase. But if you are in access phase, again you are checking for the periodic signal and transfer signal. If these two are equal to 1, then you are again going to setup phase. But if your transfer is equal to 0, you are simply going to idle phase. That means there is no other transactions. Only this is the last transaction. Okay. Now, if your period is not equal to 1 itself, you are going to stay in the access phase itself, right? And in the output, if you are in idle phase, you are making all the signals to equal to 0. But if you are in setup phase, you are going to make your P select to 1 and all the other remaining signals to their respective signals. PW data will be given to W data, P write will be equal to write. These signals we are getting from the test bench. And in the access phase, your P select will be equal to 1 and P enable will be equal to 1. So this is how we are going to develop a simple code for our APB master. In the next session, we are going to see how to develop our test bench. That is nothing but our APB slave. So that's all about this particular session. Thank you.